and I'm the coordinator for the Oakland County SISMA. So what is a SISMA? It stands for Cooperative Invasive Species Management Area. And I'll talk about a bit more what that means, but we're very excited. This is the first time we've done this event, and we're very excited to see such a great turnout, and hope that you'll learn a lot today. What are invasive species? So just to make sure that we're all on the same page, invasive species are ones that are not native and whose introduction causes or is likely to cause harm to Michigan's economy, environment, or human health. So you might be familiar, I saw many people are familiar with Phragmites and some other invasives already. Probably the most famous ones in Michigan are the zebra and quagga mussels, which have caused a lot of problems. But we've got many new emerging invasives as well that you might not have heard about. So that was the focus of today, is to talk about some of those. Thanks. All right, so why are invasive species a problem? Invasive species have few natural competitors, and this is one of the reasons that they really have an advantage. They can overtake complete environments, the way you see in that photo to the right. They also change the soil chemistry in places, and they can harm wildlife and have other impacts on the environment. They also damage infrastructure. So unfortunately, some of them can go through concrete, so through a foundation of a house, for example, through a road, through a pathway and a bridge, so they really can create problems that way. They also limit, as you saw mentioned in Janice Gilbert's video, our access to water and recreation. So this is the same wetland in 1990 and 2012, and you may have experienced this in your area as well. When Phragmites really started to invade a lot and really choke out any access to the water. So, and of course this impacts our property values as well. So if the reason that you got your house on the lake was so that you could use the lake, of course, so you want to be able to get out there and get to the lake itself. Some invasive species also present other hazards, safety hazards, including a fire hazard. So dry Phragmites is really prone to burning, and it burns very hot. So there was a big fire near Great Lakes Crossing Mall in this area in 2012, and it actually burned over 100 acres. The fire wasn't started by the Phragmites, but the Phragmites, the reason it burned so much and so long was because of the Phragmites. So it can really be dangerous as well. We really don't want that around. In this case, they had to close I-75 for a little while, and there was some impact. They actually had to have people leave some businesses and homes just in case, because it burns so hot, it's hard to control. Invasive species often form monocultures, and this just means that an area is made up completely of that one species. So you see the person standing with the Phragmites sort of in the middle of that, so how dense it can get. And this means that, as mentioned in the video, not too many things can live in there. So on the lower right, you see a more diverse native environment, and this has much more opportunities for the wildlife as well. All right, so you've heard me mention this term, Cooperative Invasive Species Management Area. So I think this is a really exciting idea because it's a way to approach something that can be a big problem in a very unified way. So the idea of a SISMA is that we work across boundaries. So that means we work with local government, state government, federal government, businesses, homeowners, really everyone. So the idea is to agree on some goals that we want to work on and then figure out how to approach them together. And by doing this, it means the best use of our resources, but it's also the best way of controlling invasive species. Because by doing a comprehensive approach, we have our best chance at controlling these species. So the Oakland County SISMA, we are the only one county SISMA in Michigan. Michigan now has 21 SISMAs, and we were founded in 2014. So, but you can see why. I know it's a little hard to read, but if you're familiar with Oakland County, which you probably are if you're here, it's a very complex county. So we've got over 60 municipalities, and so in order to get the information needed to all these different areas, we benefit from having just one county in our SYSMA. And you see that many of the municipalities in this area are partners of the SYSMA already. That's where I put the little SYSMA logos there showing that. So we started with about 19 partners, and now we've grown to over 30. And you see them listed there. So we partner with townships, cities, villages, county agencies, land conservancies, other nonprofits. So some of those organizations you see here today. Okay, so what are our priority species? And I'm just going to go over this quickly because you'll get some more information in some of the other talks. But the ones that we're really focusing on right now are Phragmites, the swallowworts, knotweed, frogbit, and red swamp crayfish, which you'll hear about, and flowering rush. So Phragmites, I'm not going to go into this much because you just saw something about it, but we know this can have a big impact on the environment and has a lot of safety concerns associated with it as well. The swallowworts are one that are a problem, especially in the northwest part of the county, so Holly and Rose and Springfield townships. They're a problem especially because they're toxic to livestock. And they're one that the SYSMA has been involved in before, but this wasn't able to completely eliminate it from the area. So I'm very excited that this year an entomologist at Michigan State received funding to release a moth as a biological control for swallowwort. So that will be starting up this year. And the hope is that this moth will be able to control the swallowwort eventually in a much larger sense. So this was successful if you've heard of a plant called purple loosestrife, an invasive that's been around for a while. So they were eventually able to come up with a biological control for purple loosestrife, which though it doesn't completely eliminate it, it does keep it much more in check than it would be if we didn't have that biological control. So we're very excited to see what happens with this moth and if it is indeed able to get us a better control for swallowwort. All right, knotweed, as I mentioned, this is the one that can break through house foundations. It's also difficult to control, so with invasives, it's really important to remember to look into, as Janice Gilbert was talking about, the biology of the plant. We really need to understand what we're working with, and then we need to understand what's the best way to control it. Unfortunately, it's not like your grass. If you go out and mow it, that might actually promote additional growth. So there's a reason that these invasives take over. They have a lot of characteristics that are kind of unusual, and so before going and just trying to dig them up or cut them down, it's really important to know what plant it is you're dealing with and what are the best methods to control it, because otherwise you might end up actually making the problem worse rather than better. So this is another reason the SYSMA is here to provide that information. All right, so what are our accomplishments so far? These are just a few of the kind of broad scale ones. We've been funded for several years by the State of Michigan's Invasive Species Grant Program with awards, large awards in 2015, and then it helped us develop a strategic management plan. And then more recently, funding to support a full-time coordinator, so that's me, and then also for a technician. So we just hired Emily Messick. Emily, do you want to wave? She's in the back there. So we now have 2 staff members of our SYSMA, which is great. We've had a number of dedicated volunteers that have been helping keep the SYSMA going for a long time, but this additional staff helps us just do more events like this event today. We also have a very successful cost share program with the Road Commission, which many of the municipalities will match that funding at 50%. So that has been really great in helping control Phragmites along roads, and that's important because roads can be a vector for the spread as well. Okay, so this is just a brief overview showing where treatments took place. I know it's a little bit hard to make out there. We're sort of in the center where Waterford is, but overview, what you can see is we are controlling Phragmites in a lot of areas around the county on county roads, over 93 miles last year. Things that we're working on this year include trail and right-of-way surveys. We're going to be doing surveys for a new invasive European frogbit, which you'll be hearing about in a little bit, and expanding our public outreach presence with events like today, and also meetings with homeowners associations and lake associations. All right, we do have some things that are already available for you to use. So hopefully you take a copy of these when you go home. These are at the SYSMA table over that way. And you can ask us about best management practices. How do I deal with these different invasives? We also are working on some revised lists of contractors. So if you have a project that's too big just for you to handle, or you just want to have some advice on how to do it, we're working on some updated lists for that as well. All right, and so finally, how you can help. So there's many ways, and the most important way is really to just prevent the spread of invasive species. So you can do that by clean, drain, dry your boat, and these other things that you've probably heard about, like don't move firewood because it moves the pests. You can learn more today about how to report invasive species if you see them via missing. You can control invasives on your property and restore or replace them with native species. And you can volunteer to map invasives or help remove invasive species. All right, so with that, I just want to acknowledge all of our funding sources and all of our event sponsors for today. We're very grateful for all of them. And I'll leave you with the contact information. There's also my business cards are over on our SYSMA table, so feel free to take that. You can check out our website and our Facebook page. And with that, I'm going to turn it over to our next speaker.
Hello everyone, my name is Nathan, and I'm the Aquatic Invasive Species Coordinator for the Fisheries Division of the Michigan Department of Natural Resources. So I spend a lot of time thinking about a lot of these nasty aquatic critters, how we can prevent their introductions, how we can respond to them when we know that they're infesting some of our water bodies, and then coordinating with a wide variety of agency individuals, researchers, and members of the public to try to control these organisms when they do get introduced. So today I wanted to spend some time talking about one of the more recent invaders on the horizon here that we recently found in Michigan, which is the red swamp crayfish. So I do have a couple specimens here in a jar. They're not live, they're preserved in ethanol. But I wanted to give you an up-close look at some of these species to give an indication of what you might be looking for in case you do have one of these tiny lobsters show up in your backyard. So I'll hand it off here if you guys want to just pass it, kind of snake it back and forth. So red swamp crayfish, the backstory on them, they are native to the U.S., not to Michigan, but they're historically found in the western Gulf Coast range, so from Louisiana down over to about Texas area. However, they are also one of the most widely spread invasive species that we have really across the world. And this is primarily because of their interest as a species to eat. They're widely distributed in the biological supply chain for use in classrooms. They also show up in pet stores as well as bait stores, which, as we know about many of these species, if you use them a lot, chances are it has an increased risk of being released into the environment. So because of that, they are now found in over 100 countries worldwide. And they pose a lot of different threats to our native system. So on the ecological side, they can influence our native crayfish species. They can help compete our native species and consume a lot of the plants and other fish species that are present in these water bodies. And they also have concerns from a social standpoint and an economic standpoint, because they have this tendency to have these really extensive burrowing networks. You can see in that picture there, and then actually a real picture here in the field. And oftentimes these burrows can be 4 or 5 feet deep into the ground. And when you have these incredibly high numbers that we oftentimes see these crayfish in, this can lead to bank erosion, it can lead to bank destabilization, so someone walking along the shore might quite literally fall into one of these things. Oftentimes you can stick your entire arm into these burrows. So if that's a problem from an infrastructure problem or a standpoint, as well as a landowner perspective, if you own some of these pond or lakefront properties. And in terms of their presence in Michigan, it's, like I said, it's a very recent issue that we've become aware of. The first indication that this was a potential problem was in 2013, when we had several anglers reporting some carcasses of red swamp crayfish along the shores of some very popular fishing spots on the western side of the state. And the concerns over these potential introductions into our state led to a very widespread and high-intensity effort to try to document any known infestations across the state. So from 2014 to 2016, The collaboration between Michigan DNR, as well as Michigan State University, and many other partners did a statewide survey of streams across Michigan, and thankfully did not find any wild red swamp crayfish in the state. But as part of that work, they also conducted a risk assessment that I'll be showing some results of later on here today, try to evaluate the potential risk of this species being introduced into our native water bodies. And also, along that timeline in 2015, the species was listed as a prohibited species in the state, making it illegal to possess any live individuals. And again, this was hopefully to try to prevent the risk of these species getting out and getting established in our water bodies. Fast forward to 2017, we received 2 independent reports from 2 different water bodies, one in the southwest part of the state and one in the southeast part of the state, that reported observations of a red swamp crayfish-looking organism. And after some follow-up surveys by the Fisheries Division of the DNR, did confirm that both of these water bodies were infested with live red swamp crayfish. So that led to a very widespread and thorough response effort. So pictured here is Kelly Smith from Michigan State University. As part of his master's work, he was working on this red swamp crayfish problem, and unfortunately he wasn't able to make it down here today, but he has been, quite literally been the one at going toe-to-toe with this species. He's been implementing a lot of these response actions across the state, and has been a really key player in our work that we've done to date. But for our response action, we tried to take a kind of a multi-tiered approach to try to address this issue. So the first one, trying to figure out where exactly these species are within our state, and trying to evaluate how good are we at detecting them if in fact they are in some of these water bodies. We're also looking at trying to prevent the spread or additional introductions. So as I mentioned, some of those risk assessments that were done in the past, we try to evaluate what are the potential ways that this species could be getting introduced, and how can we close those gaps in our state to try to limit their further spread and introduction. And then finally, we're looking to implement control actions, so where we know that red swamp crayfish are already present, how can we try to control those populations and eradicate them if at all possible. So I do want to mention that media outreach and public involvement has been an incredibly large part of our efforts to date. So from those initial introductions, there was a widespread media blast, which involved some pretty eye-catching headlines there, including my favorite, which is the tiny lobsters of doom there at the bottom. And this was really to try to engage people and get people aware of this issue and encourage the public to report any of these lobster-looking critters that might be red swamp crayfish. Because ultimately, if we have any chance of successfully eradicating or controlling these populations, early detection is really the key element of that, and we need to know about these populations as soon as possible. So after that media blast, that led to over 100 different reports of potential red swamp crayfish in the state. And you can see that they are concentrated down here in the Metro Detroit area, but also a few other reports across the state. And although most of these were not red swamp crayfish, thankfully, most of them were native species, those reports are still really informative because it does give us an indication where they might be, and also helps us learn a little bit about the native species along the way. So we have some kind of added benefit of going out to check these populations out, and also can learn about the species that we actually want to see present in our water bodies here in Michigan. So in terms of responding to these reports, as I mentioned, this is an incredibly extensive collaborative effort. So although I'm the one here standing in front of you today, this has really been a huge effort from both the DNR, Michigan State, Michigan DEQ, multiple SISMAs across the state, other lake association type groups, and then ultimately anyone that happens to catch one of these species or happens to see something that might be a red swamp crayfish have been a major part of our work here. So I've highlighted there at the bottom, you can help. Full disclosure, I'm here to try to recruit you as best as I can to alert me if you happen to see some of these species. And I'll have some information at the end about how we are encouraging different avenues of reporting, some of my contact information. And I also have some materials over here on the tables, so I might be able to help you identify these species if you come across them, and also the next steps of reporting them if you do come across them. So our early detection and surveillance effort has prioritized focusing on these ground zero hubs around the state. So where we have gotten these initial infestations, We've really been focusing our efforts. These are 2 examples of some of the early known infestations there in the X. And you can see all those purple dots as the place that we found actively surveyed. So we're really concerned about critters maybe wandering from pond to pond. So we're looking to hone in on those areas to better understand the current status of them across the state. And then you can see those purple dots outside of those zones. Those are all instances of us responding to those public reports that have been outside of our area of focus. And I mentioned we've been trying to also get better at our job along the way. So we're trying to evaluate what's the best strategy to go out and identify these things in the field and get our hands on them if, in fact, they are present. So we've been using 2 different strategies. One being using baited minnow traps, using dog food is a very effective way to catch crayfish. And we're also using some newly developing technology called environmental DNA, where we can sample the water, filter down that water, and through the DNA that was floating in that water can detect the species that are present. So it's a very CSI-like approach to detecting species, but it allows us to have 2 different gears that we can compare and say which one seems to be doing a better job of detecting these species when they're at potentially very low abundances in some of these water bodies. So this is a map of our current sampling efforts across the state. You can see it's all focused in the southern region here, with the 3 epicenters identified by those circles. All these black dots represent places that we've gone and either put traps out or conducted the environmental DNA surveillance to try to detect the species if they're present. And this has involved a lot of effort, so just over 200 sites, over 7,000 traps that have been put out, and just shy of 200 DNA samples. Thankfully, not very many of them had red swamp crayfish. Currently, only 21 known infestations have been confirmed, with an additional 4 having EDA detections, and we haven't subsequently detected any live, so we've got our hands on the organisms, nor have we gotten additional EDA detections. So those ones are unconfirmed right now. You can see those blue dots there. All those 21 infestations are focused in those epicenters, which those 2 there on the east happen to be in Oakland County, so these are right here in our backyard down in the Novi and Farmington Hills area, and that has been one of our hot spots in the state for red swamp crayfish being present. And I also want to point out that all but one of those are on private land, so interacting with the public, again, is a huge part of this, and having communication and collaboration with landowners and business owners that have these ponds has been a really important part of us being able to implement some response actions. And to date, all these infestations, or most of them, have been in very small retention ponds. Think the pond that's at the Walmart parking lots, golf course ponds, those have been sort of the hot spots of where these species tend to pop up. On the next level, on the evaluating our organisms in trade, trying to limit the new introductions, there's been a whole lot of effort focused on finding them in pet shops, in the live market trade. There's Kelly there doing some outreach at a local school, talking to teachers about how they're using these species in the classroom. And to date, or this was back in 2014 and 15, and still those red dots there are all places that were actively selling, either knowingly or unintentionally, red swamp crayfish. So this is most likely the pathway that has been leading to these introductions, because as people are using them, whether it be for food or for education, and then either accidentally release them or intentionally release them, ultimately that's how these species can get established in some of our water bodies. So not coincidentally, the hot spots seem to be in some of the areas that we've been finding red swamp crayfish in the state. And on the education side of things, so that's the colored in counties there. All the reddish colors represent potentially risky actions. So these are either crayfish that are being sourced from a potential place that might have red swamp crayfish, or they're disposing of them in a risky way. So a risky way being dumping them down the toilet, letting their students take them home as pets. Those kinds of disposal methods have a high likelihood of ultimately winding up alive and in a natural water body. So as you can see, there's a lot of different pathways, and we're trying to limit them as much as possible, because there seems to be a lot of different potential ways that these can be being introduced into our water bodies. So moving forward, we continue to work on evaluating these potential pathways, limiting them as much as possible. Also, the law enforcement part of it continues to be a really important vector. As recently as 2015, there was a very large shipment of red swamp crayfish that was stopped coming across the border from Canada. So trying to close off all these potential pathways as best as we can continues to be a very important part of our work. And moving forward, we're going to be, as I mentioned, developing some control actions. So where we know that they are present, how can we try to remove them or eradicate them completely as possible? We're working on developing some site-specific, so at the pond level, which treatment method might be the best one to use. Hopefully we don't need to result in very extreme measures in order to try to get rid of them. But we're really exploring all options that we might have available. So extensive trapping, exploring use of chemicals, biological control by stopping predators. We're trying to evaluate all these different methods that might have a chance at trying to eradicate the species where they're found. So moving forward, we have a really busy season planned ahead of us. We're going to continue to implement our surveillance efforts, start ramping up the efforts on the control side of things to see if we can eradicate some of these populations, and continuing to evaluate the potential introduction sources and how effective these regulations seem to be at limiting additional introductions will also be a very important part. So that I want to acknowledge, I mentioned this is a huge collaborative effort. And full disclosure, I just started in this position about 2 months ago, so I did almost none of this work that I just talked about. So this has been a very, very large effort by a lot of people. So I just wanted to give acknowledgement to all of them. And our funding source is the Great Lakes Restoration Initiative, has provided all the funding needed to implement all of this work. And then last but not least, I promised you I was going to try really my best to recruit you as eyes in the field. Red swamp crayfish, as they pass around there, are most obviously detected based on a very miniature lobster-looking appearance. They can get quite large. They're oftentimes larger than our native crayfish. And their telltale signs are typically the red color, but also they have these very pointy, bumpy, we call them tubercles, the little bumps on their claws. So if you got a chance to see those are usually the best giveaway of the red swamp crayfish. But then also those burrows is another giveaway too. So we have some native burrowing species, but if you see a really, really high density of burrows, that oftentimes is another telltale sign of red swamp crayfish. So if you happen to come across any of these things, snapping a picture is ideal, and contacting me, I have my email address there. You can also Google red swamp crayfish Michigan, and it probably won't take too long before you come across my email address. So by all means, if you come across something that looks suspicious, please reach out, and we'd be happy to come and investigate further to see if we can figure out what's going on. That's it. Thank you, and I'd be happy to answer any questions you might have. And before I forget, I want to remind you all all this swag I have.
I do have one question.
Yeah.
So a lot of those pictures you showed them out of the grass, they commonly come out of the water and reverse.
Yeah.
Okay.
Yeah. So you notice the title of my talk is "What's That Tiny Lobster in My Backyard?" It's a very applicable title because they do wander from pond to pond. So some of these golf courses, they've been noted running across the fairways. Some of the reports we got were literally someone saw them in their backyard. So they will wander from pond to pond. We don't know exactly how far they go out of water, but they definitely are making movements from outside of the water. Yeah, in the back.
You were talking about, excuse me, shipments of them coming in.
Yeah.
Well, are they used for food or something, for animals, or do people eat them, or what's
Yeah.
the value of them?
Yeah, so the big thing is human consumption. So as I mentioned, they're native to that Louisiana to Texas range. And if you've ever heard of kind of the authentic crawdad broil, this is likely the species that they're talking about, that they're eating. So they do have a high value from a food perspective. The concern being embracing them as a food item just further increase the likelihood they get introduced here. So that'd be why we're not encouraging that we eat them here in Michigan. So they are prohibited species, so we cannot possess them for consumption here in Michigan. But yeah, that is the primary reason is to eat them.
I'm from Louisiana, yeah, they're really good.
Yeah. You're not supposed to say that.
How cold, it seems like they wouldn't live here because it gets so cold here. It seems like they could.
Yeah, so that was one of the kind of the thoughts of why they haven't shown up earlier. Was maybe that it's too cold up here for them. But we had a pretty nasty winter. I'm hoping we go out this year and they're nowhere to be found. But they have made it through at least, again, this is a really recent issue, but they at least made it through one winter now that we know of, 2017 and 2018. So they seem to be able to survive, most likely because of those burrows. They're able to dig down and escape that frost line, and they're able to dodge, that really cold weather.
You did mention that they burrow similar to native crayfish. Are they larger, those chimneys that stick out of the ground? Are they, because they're going that deep, and soil's got to come up, right?
Yeah, so they can be. The burrows are really variable. So sometimes they're very tiny, you can barely see them. And other times, like I said, you can literally put your entire arm up to your shoulder. So they range. Usually the big difference you can tell from the native is that density. When you see them in those incredibly high densities, they're scattered across the entire shore. That's usually when it's the sign that it's not a native, in fact, that it's not native. But I don't want to cut myself off, but I'd be happy to address any other questions. I'll be here throughout the afternoon. I mentioned I have the table set up there, so feel free to come by and ask any additional questions you might have. Thank you.
Great, so next we have Tom Alwyn from the Michigan Department of Environmental Quality.
My name is Tom Alwyn. I'm an aquatic biologist with the Michigan Department of Environmental Quality. We'll soon be going through a name change, which is kind of exciting, so I'll no longer be DEQ. And I think I have one of the best jobs in the DEQ. And it's not just because I'm here getting to talk to you guys today. In the summertime, I get to go out and do a whole lot of field work, and I don't have to deal with crayfish that try to bite me. Or trees that drop branches on me. I mess around with aquatic plants, which is pretty sweet. So I get to go out on lakes, I get to go out in wetlands, and mess around with aquatic plants. It's a good gig. So today I'm going to talk to you guys about European frogpit, and talk to you a little bit about early detection and response. And so European frogpit is pictured here, these little cute lily pad looking things. And that was probably all open water. I was not at that site prior to European frogpit being there. That was probably all open water, so you can see just the impact that this little guy has. It's probably one of the cutest little plants you see out there, and it really is a cool looking plant. And you can see it has little white flowers right there. And that's probably about all I can talk about on this page. We'll go through a little bit of identification. Before I talk about that, I'll talk about sort of the history of frogpit in Michigan. And with that, Ben, you can click me forward. Thank you for being the clicking guy. So early detection and response is a methodology of trying to find something early before it gets too far gone. And this is called the invasion curve. And this is really just a generalized curve that can be used for any species or any invasive species. And you can see based on the bottom, you can look at it as the species population or just time. You can also think of it on the y-axis as either the cost to deal with that species or the amount of effort to deal with that species. And so you can see in the very beginning, we're going to say that the species isn't here yet. So prevention is what we're working on. That's the most cost-effective way of dealing with invasive species. Make sure that you don't have to deal with them at all by not having them not get there. Now you can see there's a little bit of cost because I may come out and talk to you guys, or I'm out looking around in the state trying to make sure that that species isn't there. So there is some cost involved with prevention, but it's pretty minimal. So at this first dotted line, the species shows up, and then you have this brief window where you can eradicate it, and that's the early detection response period. That's when you want to find that species. You want to get out there, you want to work on managing it. There's a lot of species that have been mentioned already, Phragmites, purple loosestrife, that have gone past that, out into controlled containment, and even out into asset-based protection. I don't want to talk about any of that because we don't want frogpit to get over there yet. And on a statewide scale, frogpit is maybe a little bit outside of the eradication period. We're not 100% sure. There's kind of some gray lines there. But on a more regional and a smaller scale, we think that it's still in the phases where it can be eradicated. And that's an important part about the invasion curve as well. So I think of it from a statewide scale. If something's in the state, it's maybe in that eradication or past the control period. But for Oakland County, you could envision yourselves using this graph just for yourselves, for any species. So you may not be in Oakland County yet, so you can still be preventing it from coming into the county. That's Ben. So what we have at the state for aquatic invasive plants is an early detection and response initiative. We're funded through GLRI funding to basically shoot for this goal. And all the species pictured up here are the ones that we have targeted as early detection species. Frogpit is that guy in the middle with the white flower on top. And So we have a process that we go through when a species is detected in a location to determine if it is actually an early detection and whether or not we can respond and actually achieve our goal of eradication. So at a statewide scale, frog bit, we're not quite at the point of feeling like we can eradicate it, and we'll get to where it is. But in Oakland County, we're still sort of figuring that out as well. But we have a site out in western Michigan where we are trying to eradicate this because it's not really common out there. Next, Ben. And so you can see the early detection response history from the program. It started basically in 2010, and initially it was funded through DNR, and they did a bunch of work. In 2017, it was transferred over to DEQ, which is when I got more involved. And all of these little dots are areas with various species. The colors determine the species. Green is European froglet, so we got it down here. Got it right there. Got it all the way up along the Lake Huron shoreline. And the other species are different colors. I won't talk about those guys. But so this is basically the 2017 and on data. DNR has data that I don't have all the access to, so I didn't include it in here. But this is also a picture. I mentioned West Michigan. This European froglet site, that's in Reeds and Fisk Lake in Kent County. And that's us out hand pulling froglet in a wetland out there. And I think I have some more pictures of that one just because we've been pretty heavily involved in that. Next, please. Looking at it more from a statewide scale and then talking about the history, you can see this is from Missin, and I know Missin has been mentioned several times before. That's a tongue twister. But you can see where European froglet has been reported in the state, nicely a lot of the way along that Lake Huron shoreline, and then there's one blip out in Kent County. That's one of the reasons we focused on that one for early detection and response. I have kind of the real general history of how it has spread, or at least how we've known it to spread. It was first found in '96, and it made it all the way up to the St. Mary's River by 2014, and then Kent County in 16, and then this past year, it was reported in Oakland County. And so it's interesting to see how it can spread all the way from Lake Erie almost to Lake Superior, but not have made it, inwards past Monroe and Wayne counties to get into Oakland County. It took it a long time to make that jump, and we're not sure exactly how that jump happened. We're not exactly sure how it spread all the way up the Great Lakes coastline. We have some suspicions, but we don't really know. So we try to promote prevention through, education and outreach, but it's made its way inland to Oakland, and so now we have to start thinking about, is it something that we can eradicate in the county? Next, please. So we'll move into Oakland County now, moving from the state level down into Oakland County. I have the 3 initial sites that it was reported in 2018. And, as I said before, mostly it's along the Great Lakes shoreline. There's that Kent County one, there's another one up in Alpena that's inland. So these are the 3rd, 4th, and 5th known inland reports of European froglet. And then, as I said before, we're sort of working through our program and our process to determine where it is in the county, how much of a problem it is, and from there we'll be able to make some determinations on management actions. Next, please. Map doesn't show up too well, but you can sort of see the monitoring that we've done, and I've color-coded some things, and those don't show up all that great either. I apologize. But you can see this is Mayberry State Park. All of the dots are sites that have been monitored looking for European froglet last fall. So it was found fairly late in the fall. We didn't have a lot of time to go out and do a lot of surveying. But we did coordinate with the Oakland County SISMA and go out and do some monitoring, looking and trying to find it. The only one for Mayberry is that red one with the arrow pointing at it. None of the other sites had any froglet in it, so that's very encouraging. As we moved up into Novi and looked around, we did definitely see some more. Island Lake is the arrow here. And that one, we found one pond with froglet in it. The other ones are all green. And I believe there's a couple purple ones that we need to revisit. We had some data that we weren't sure about after the fact. So we're going to revisit those in 19. And then Ashbury was another site and that's a subdivision, and there's 6 different ponds some of them connected to one another that have frogbit in them. So that's probably our most concerning one at this point. But if you go to the next slide, we took some time to use maps and figure out small water bodies in the area. And you can see that there are close to 300 water bodies, just like detention ponds, like Lucas was saying, small water bodies that need to be sampled. So it's a big lift and a big effort. And it's very different than any of the other frogbit sites we found so far. Great Lakes shorelines are pretty distinctive. You know, it's the shoreline, it's a little bit inland, it's a little bit out to the water. The site out in Kent County is a single inland lake. It hasn't been spread to any of the other inland lakes. But these are all very small bodies of water, and they're all interconnected. So we're not really sure what's happening or how quickly it's going to be able to spread through a system like this, but it's going to take a lot more looking than the other sites that we've had to do. So our plan is for this year to work again with the SISMA to go out and do monitoring. We're going to try to catch all of these sites. And the really scary thing is as we're driving around, we're like, there's a pond that's not on the map. There's a pond that's not on the map. So I suspect 300 is actually a very low number. Probably a lot more than that that we're going to have to try to look at. But we're going to go out, we're going to try to figure out where it is exactly, and based on what we find, we'll be able to determine what the next course of action is. There'll be some level of management. Frogbit can be managed with herbicides, it can be managed with hand pulling. So far, we're learning a lot as we've worked to eradicate it in West Michigan, and we're going to apply what we learn to these sites as best we can, and try to get this thing nipped in the bud. Next, please. So I wanted to talk, similar to Lucas, to you guys and encourage you to keep your eyes open for European frogbit. So we'll talk a little bit about the plant and try to get you up to speed about what it looks like. I don't have any in any jars. I didn't bring any with me. It's too early in the season for it to be growing. But this is from the Ashbury subdivision. And all of the green floating is all European frogbit. Now, it's not a very big detention basin, but it's pretty well covered, which suggests that frogbit's been there for a while. At least a season, if not maybe more. But we don't really know when it got there. We don't know how long it's been there. But it grows to cover the surface, floating leaves, forms dense mats. It's got roots that hang down, and those roots make it harder for fish to pass through. It can just sort of clog up the shallow areas of the water bodies. And it does like slow-moving waters. Thank you, that's good. It does like slow-moving waters. So out in the Great Lakes, it'll grow in and amongst cattails and phragmites, but it doesn't really grow in open water. There's too much wave action. So these little ponds are really calm. They're perfect habitat for it. So it potentially could get very bad very quickly in there. So this is an image, more of a drawing of a close-up of the plant. And you can see sort of the different pieces of it, and some of the details. One thing I wanted to point out, this red arrow, that's generally how the plant reproduces, or how our best understanding of reproduction is, and they're called turions. They're like an asexual reproductive structure that form when the plant is stressed late in the season, and then they drop off, and then they form into new little plants, which you can see in the little inset. It does flower. It does produce seeds. We honestly don't know how viable those seeds are. We have some researchers who are trying to figure that out by collecting seeds and seeing if they can sprout them. So our best understanding is it basically moves around by being attached to boats, potentially attached to wildlife. It could be that things are eating the turions and then excreting them. We're not sure if that's a possibility. But that is what it looks like in a nutshell. Excuse me, next. There are some lookalikes of the plant. A couple of them are pretty not close lookalikes. Lily pads, they look like lily pads, but lily pads are very large leaf, so the leaf size is pretty distinctive. There are some juvenile, There are some juvenile lily pads that kind of look like frogbit, but that would be these guys. They generally have a big root tuber on them, where frogbit is just fine, feathery roots. Next, please. And then, if you wanted to take some time and learn some more, the State of Michigan's Invasive Species website has a little bit of information on it, including a status and strategy document, which won't reflect Oakland County because it hasn't been updated to reflect that yet. The Michigan Department of Ag and Rural Development also did a weed risk assessment on the plant, that suggests it's highly invasive for the state. And good luck copying down that URL. Sorry, we have no new URL. I think next. And this is from that West Michigan site. That is a day's work of frog bit in garbage bags. And I wish I remembered the number. We pulled thousands of pounds of frog bit out of that one water body, including also doing herbicide treatments on other portions of it. So the plant is fierce, and it is in Oakland County, and we are working on it, and we're working with the SISMA on it, and we will be doing our best to eradicate if we can. And I'm probably over time. So thank you. I'll be around for the rest of the day, so just grab me if you have questions. Thank you.
Hello, everybody. How are you?
Good.
How many of you have heard about oak wilt before? Good. This will all be reviewed. You're all experts already. Fantastic. My name is Wilt. I'm known as the oak wilt guy. I work currently for American Arbor, LLC in Three Rivers, Michigan. Before that, I worked for almost 10 years for the Michigan DNR, running the oak wilt mapping and community outreach project. Okay? So today we're going to talk about where oak wilt is. Why do we care? I mean, I don't think I'll have to convince any of you why we care, especially if you're all oak wilt experts already. How do we identify it and controlling its spread? Is there any way to get the lights turned down a little bit? Because I've got some really nice pictures of pressure pads that will just look like gray nothing with these lights on.
Yeah, I'm on it.
Anyone? Thank you. She's on it, everybody. Okay, so oak wilt. When it shows up in, most of the time when you get a phone call, it's because a landowner has got several years worth of mortality. You can see here these expanding pockets of mortality. Much better. You can see the dead trees in the center and the newly flagging trees that are symptomatic on the edges. That's usually what you see after it's been there for a while. But usually, and this is the better scenario, when you find just one tree in an urban landscape, it's much easier to control and it's much less expensive when it's that first tree and you catch it when it's just starting to flag. We'll get into that later. Okay? Michigan's oak resources. Again, I don't need to convince you people why this is important. You know, Michigan's economy, forestry, contributes to air quality, water quality, blah, blah, blah. Beauty of trees and stuff, and critical habitat, food for fuzzy creatures, okay? But this is something that not a lot of people know. Oaks support an amazing array of insect larvae, including over 550 species of caterpillars. These are critical links in the food web, and a lot of them feed baby birds. Yeah. What kind of monster doesn't care about baby birds, everybody? Okay? So here we have, as of 2002, we have county-level distribution. This is all known oak wilt. These are counties that were positive for oak wilt as of 2002. But this doesn't tell us much. In 1881, these symptoms were first described in Wisconsin. Not saying that that was oak wilt, but they suspect that it was there because the symptoms of oak wilt were described. The causal agent was not identified. 1944, a causal agent is identified, later named Ceratocystis fagacearum. 1970s through the 90s, it expands. Okay? So here we are in Michigan. All right? We have this county level data. This is as of 2002. See, I'm a Canadian, so I'm always fascinated by these American maps. Right? Like, it's like, what's there? It's like, here be sea monsters on every American map. It's always the same thing. All right, so 2005, I started with this. We had this county level data. Again, this doesn't tell us much. This could be 1, this could be 50. Needed better data. So here, fast forward to 2014. Most of those dots are places I went and did confirmations. 2014, 2015, we get a new county confirmed. Now this is important. We've got not detected, confirmed, and we've got historical reports. Can you guys see the differentiation color there? Historical reports means that the DNR, or one of the other agencies that follows this, doesn't actually know of the report. But somebody at some point, at some time, sent a report into one of the labs, either Michigan State University or Michigan Tech, one of the other ones, there's a couple in Wisconsin or something, that monitor this stuff. And at some point there was a positive, but that's private information. A couple of times I tried to ask the different labs, hey, can you get that information for us? And to do that, they have to send a letter to the person who sent the sample in, ask them permission to release that information, and they either didn't respond or just said no. So, but we do have county level. So at some point, sometime, there was. So anyway, so let's go to 2016. Oh, something showed up there. We're down here. What is that? Where's that? Where do you think that is? Anybody familiar with Wayne County that well?
Belle Isle.
That's Belle Isle, right? And this was especially important to us Canadians because this is only 574 meters from Windsor. All right, we're going to get some biology. You guys are all experts. This will be old hat for you. But we're going to start with biology. This is the oak wilt disease cycle, right? It starts off with the tree dying. You can just imagine me pointing. Tree dying. The tree becomes symptomatic, loses its leaves. The pressure pads form under the bark. We're going to see a lot of pictures of pressure pads. No, it's okay. I appreciate it. I need both hands to do this, but thanks. So then the pressure pads form. The beetles, the nididullids, the picnic beetles, visit the pads. They get spores on them. They transport it to wounded trees. This is important. This is one of the only silver linings to this great cloud. Nididullids do not have the chewing mouthparts to inflict wounds. So they can only spread to wounded trees. This is one of those things that it's like, well, we can control that. We can just not prune at the wrong time of year. I mean, sure, you might get a thunderstorm and a couple branches break. You might get a new infestation that way. But if that right there is a crucial part to how this disease is controllable. Okay? But let's say little Timmy was out there with his hatchet and he was whacking on the tree. He caused some wounds and the nididullids landed on him and infected the tree. And the tree became infected and you get the discoloration, the vascular tissues, blah, 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 and it spreads like that. They also spread underground through root grafts. We're going to talk about that. As we said, it's 2 ways. All right, it spreads 2 ways. We've already been through this. Nididullids, also called the picnic beetle, they are attracted to sweet smells. So the fungus gives off a smell that's very much like juicy fruit bubble gum or fermenting apple cider. My Jedi Master Bill Cook up in the UP who taught me oak wilt says it smells like a good vanilla ale. That's true. Anyway, so if you've ever been eating a piece of watermelon or something at a picnic and little beetles are flying around your head, that's them. They're natives. Again, we've got the root grafts, which is the second way, which is underground. So oaks in the same subgenus will form, and grafts between reds and whites are less common. There's actually a recent paper that was done, I think, by Jennifer Jeswick, Dr. Jennifer Jeswick, who went around and actually, I think, did some work on this. It's a little more common than we thought. I don't know the percent off the top of my head, but it's not that it doesn't happen. Okay? This is a typical oak wilt leaf that's on the ground. It kind of has that greenish tinge or tawny, leathery tinge towards the petiole and gets burnt. It's almost like someone held the leaf by the petiole in a toaster for a little while, you know. But that's symptomatic, but that's not diagnostic. Okay? Hosts, we've got reds as the most susceptible. If a red oak gets the disease, it's dead. Okay? Within a couple of weeks, the tree will go from being completely green and looking nice to all of its leaves on the ground. Yeah, it's pretty spectacular. And then you've got burrs as an intermediate, and then you've got white on the other end of the spectrum. When whites become infected, they're better at compartmentalizing the disease, so it doesn't spread through them like it does with the red oaks and kill them so immediately. Okay? Spore mats. Spore mats form mainly on red oaks. These are those pressure pads we were talking about in that disease life cycle. Okay? They very seldom form on whites. Now I asked Dr. Jeswick if she had ever seen a spore mat on a white oak, and she said yes, a couple of times. They're usually very small. I've been doing this for more than 10 years. I've looked at literally thousands of trees across the state, and I've never found a pressure pad on a white oak. I'm not saying it doesn't happen. I'm just saying that when I see that, it's going to be like finding Bigfoot riding a unicorn through the forest for me. It's going to be a big day. It's going to be a big day. So cracks and mats form. These are the pressure pads. We're going to see those now. So as you can see, these form under the bark. Okay? Can you guys see those all very well? It was good to turn the lights down, you know, because you can see these. We're going to see a lot of pictures. You can see right here, as they're nice and fresh, they have this brain texture to them. Okay? Then we got our little friend there, the nididulid. Okay? So what we have here is we have what I call pressure pad primordia. This is the hyphal mass, this is the vegetative state growth of the fungus under the bark. And then they turn into that So on a couple of occasions, I took samples of just that hyphae mass, because I said, "Boy, it smells like oak wilt." And so I took some samples of it, and before they could be plated out, I took them to the lab, and sitting on the table for a few hours at room temperature, they popped and formed pressure pads like that. So that's the primordia. So when we're talking about the cracks, they're not very visible most of the time, but you can hear them. If you have a hatchet or something, and you're drumming on the bark, you'll hear a hollow spot under the bark. Even if it hasn't popped, cracked that open yet, you'll still hear them. So you can see that's half of it. So that's what it looks like underneath. So that's this piece of bark pulled over. Right? Notice this white hyphal mass. This is when they're really fresh. Okay? Again, we've got these two cracks. I mean, if you were walking past the tree, you wouldn't even notice that right there, would you? And sometimes as the trees get older, the bark gets very craggy, so they're very hard to find. But again, even if you can't see them, you can always hear them if you're drumming on the bark. But then again, that's this whole piece peeled open, and this is what was behind it. Okay? So as they start to get a little bit older, they get grayer. You know, the bright white hyphal mass becomes darker, and you'll start to see the pressure pad itself becoming increasingly dark as it ages. Okay? As they age further, that outer mass will sometimes turn black or gray. Okay? And then eventually they start to get very dark, they start to get dry and crumbly, and they fall off. They start to fall apart. This is an interesting photograph, because you can see the age of this pressure pad. Look at the age of this one, how dry it is. That's like a 2-year-plus old pressure pad. And right next to it, what's that? Okay? The window for pressure pad formation is considered relatively short. Okay? Once the pressure pads have been dried and the wood is no longer considered infectious. This is in the statements that they use for how you treat infected wood when you're dealing with it on a piece of property, right? Okay? So what we got right here is we have a 1-year-old pressure pad, and we have a newly formed pressure pad right next to it. So that means that this piece of wood is infectious for several years. I've got a lot more pictures of this. This was the first time I saw it. And that's this tree. Look how big that is. The bark's just falling off of it, and we've got a brand new fresh pressure pad up there. That's probably 2.5 years since the initial mortality. So how is this happening? Well, I've got an idea. How do we play this? Oh, we missed it. We missed movie time. How do we go back? Let's try this. No, that. And you click on it. Okay, well, there's going to be no sound, so it's going to be like a silent movie. All right, so I'll talk over it since it's me. I'll just do my own voice. It'll be good. It's not making us believable. So here we've got a tree with a very old pressure pad on this side. So I thought to myself, how does this happen? You know, how do we get pressure pads forming on one part of the tree and then new ones forming on the other? I won't give you the spoiler. I'll just let you watch. If anyone wants to, I don't know, sing the Indiana Jones theme song while this is going on, I find that appropriate. So here we go around to the side, and oh, look, we've got epicormic branches on this side of the tree. So what we've essentially got here is, for some reason, there was a compartmentalization on this tree. One part of the tree contracted oak wilt, went through that normal life cycle, lost its leaves, the pressure pads formed, but for whatever reason, on this side of the tree, it was still alive. So in these situations, I think that's how that's happening, where I'm finding these really old pressure pads and these new pressure pads. This very, very small sliver on that side of the tree was alive. And there were conducting vessels going all the way up and down that were still working, because up high, there was there's all these epicormic branches all the way up and down this side. So all the way from like there, left, all the way around to the other side, just about a strip about that big, the tree was still alive. So I think I've seen this about a dozen times over 10 years, so I'm not saying it happens all the time. I'm just saying the understanding of how long wood can be infectious is possibly there's something else going on there.
In specific situations, as I like to say, in this universe, there are only possibilities. So now how do we manage these infections once they show up? Well, the best thing to do is to get a good confirmation, and that's all about collecting. This isn't working anymore. Want to be my button push?
Yeah.
Tom, everybody. Ladies and gentlemen, Tom. All right, oak wilt. So when we're talking about oak wilt, we can talk about prevention, identification, treatment, and management. The best thing to do is just to prevent it. Don't let it get on your property. Don't wound your trees at the wrong time of year. Don't move firewood that might be infectious. If your neighbor's doing something that you see they're not supposed to, yell at them. If the power company comes through and they're going to be trimming trees at your back of your property at the wrong time of year, yell at them, you know. So, next. So identification, keep going. So you've seen this. Next, next, next. Collecting a branch sample. Newly symptomatic trees, next. So when you take a branch sample, it needs to go to him, it has to be fresh. So branches that are showing symptoms, so not something that's too dead and dry. 3 to 5 branch sections, 6 to 8 inches long, larger than your thumb, smaller than your wrist. They have to be large enough that they don't dry out. And then you don't send them firewood because everything has to be autoclaved. And they get really upset when you're sending them logs. Next. So one of the things you're looking for is this discoloration in the cambium. Next. And you want, go ahead and hit the button 2 times. 1 more. 2 more. There you go. Go back 1. So usually I have a little clicker in my hand. It's easier to do. So where you don't want to sample from is up top there where everything's dry and dead. You want to try to sample from somewhere where there's still some green leaves. Next. 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 So, you know, you get your 3 to 5 samples, you get them in a bag, and you get them to MSU as soon as possible. Next. And there's that, you know, don't worry about writing this down. I think they're going to make these PowerPoint presentations available, aren't you? Yes? Yeah, you can go ahead and put this one wherever you want to share this.
Thank you.
You're welcome. All right, next. So are you sure it's oak wilt? There are a lot of other things that can kind of look like oak wilt. One of my favorite questions to ask someone on the phone, they call me up, they say, I've got the wilts. Really? Yeah, this guy came by, I said, I got the wilts. Oh, really? Yeah, my tree's not been looking good for a couple of years, and it's, you know, just like, probably not oak wilt. You'd know if you have oak wilt, because your tree would be dead. You wouldn't think you have oak wilt. So, next. So with 2-line chestnut borer, a lot of times can mimic these symptoms. You'll see some dieback in the upper branches. This is a larval insect, a beetle that in its larval state will girdle whole branches, and when it gets bad enough, whole sections of stem, and you'll see a lot of this dieback, but you will still see some green leaves. Next. So this is a photograph taken in Roscommon County. This is a place where, you know, they've always got gypsy moth, drought, armillaria, 2-line chestnut borer. There's oak wilt mixed in there. Sure, but, you know, try ferreting that out. Next. All right, prevention, treatment, management. Next. So if you've got oak wilt, you know, the best way I said before is to not move firewood and don't prune it the wrong time of year. Next. There are chemical injections you can do. Next. So this is a systemic fungicide called Propiconazole. It's a trunk injection. Keep going. It is expensive, depending on where you are in the state and what your property values are. Depends on what the guys are going to charge you when they show up, right? So 10 to 20 per inch DBH. It only lasts 15 to 18 months. So if you get it injected, you have to keep re-injecting this tree. So once you're in it, you're kind of in it. You're in for a penny and for a pound. Every injection port is an injury to the tree. So, I mean, and this stuff is not good for the trees. It's not like you're giving vitamins and minerals. This is a chemical that's very harsh. And so some studies have shown that the tree actually stops putting on radial growth when you start injecting it. Okay, next. Root plate excavation. This is only when you have one tree. This is that first tree. First tree in your backyard starts flagging, oh my gosh, what's going on? Call someone up, you get a confirmation. It's oak wilt. What do? You cut it down. Next. And you get as much of its root system out of the ground as possible. Next. You come in, keep going. You come in and you just, next, yank that thing right out of the ground as much as possible. Okay, good. Now the reason for that is because it is assumed, if it's a first infection, that was an overland infection. The tree is infected, the foliage has started to show signs, but it has not yet moved down into the root system. That's the technique for one spot. The other spot is the vibratory plow. Keep going. This is a very scorched earth kind of technique. This is putting in a plow line to break those root graft barrier, to put in a root graft barrier, breaking those girdling roots underground. You can use anything really that can get to 5 feet deep, right? Now where you put that trench is established by this work that was done by a guy named Johann Brunn. Okay? That's the formula for figuring it out. What? Sure. Okay, let me break it down for you. Basically, what that model says is the bigger a set of trees is, the farther their roots can grow. Not kidding, that's what that formula says. All right, so this is the regression table broken down into a way that you can use it. Okay? This deals with combined DBH of the nearest infected to nearest non-infected tree. Okay, let's say you got 26, you move across, 66 feet. DBH of infected plus non-infected tree equals the distance that needs to be between them. Okay? For the purposes of training, we're going to say that's a healthy tree, flagging, and a dead tree. Okay? When you're trying to figure this out, that guy's 15, that guy's 15, we got 30, move on to the tree, you move across, 77 feet. So those trees have to be at least 77 feet apart. However, they're 56 feet apart, so you say that guy's dead. You say, or he's probably already infected. Again, you do the next measurement to the next nearest tree, always round up, 36, 92. These trees need to be 92, and they're 102 feet. So where do you put the plow line? Put it in there. This is simple, right? Okay, well let's look at a more complex situation. So you always measure from the nearest tree out. So even though that's a dead tree in the center, it's been dead for a year or so, you always go with the farthest out tree of the periphery of the infection pocket. So you're going around, you do your measurements, finding out, no, that guy's dead, everybody else is okay, right? So your trench line goes in there. So this person says, you know, science says I'm already infected, but what can, and the homeowner says, yeah, let's see what we can do. So that's when you get into this thing called the French method. This deals with a primary and a secondary trench line. So you've gone around, you've done all your measurements, right? And you put in your primary trench line. But it's possible that these trees on the periphery are not infected. So if you put in a second trench line, what you've done there is if that tree is infected, it's not going to spread because you put in this trench line. But if it's not, you've now saved it from becoming infected. See what I mean? So then going back to this scenario, you could put in a second trench line there, and that way, if that tree is okay, then you've saved it. There are a lot of other options. There are a lot of cases where, you know, especially in urban settings where you're dealing with this situation, where you've got all these trees over here belong to another person. Property line runs right through there. And then that guy's like, I'm not going to do anything. This is all a hoax. This is all a left conspiracy. And so he doesn't want to do anything. So then what do? Well, you know, there's a lot of other options. There are a lot of tools in the tool book. Excuse me, the toolbox. Tool book. A lot of books in the tool book. I have no idea what metaphor I was trying to use there. So anyways, and, I'm going to be hanging around for about another 10-15 minutes after this before we go into our sessions. So if any of you have specific questions, please feel free to come up and ask me. Otherwise, yeah, I hope this wasn't too much of a bore to you experts. And to other people, I hope you learned a little something. So thank you very much.